Hello guys, today's video we're talking about the chapter 5 and we're going to answer all of this activity in the chapter 5. So chapter 5, which means Ethernet, and here's a little bit introduction about this chapter 5. So the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standard defines many aspects of network communication including frame format, frame size, timing and encoding. When a message are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. So, because Ethernet is comprised of standard these lower layers it may best be understood in reference to the OSI model. Then the OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standard of the media. Ethernet standard define both the layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media, bandwidth, and other layer 1 and layer 2 variation. The basic frame format and address scheme is the same for all varieties of Ethernet. This chapter examines the characteristic and operation of Ethernet as it evolved from a shared media, contention-based data communication technology to today's highest bandwidth, full duplex technology. So let's find out the first activity that we're going to answer for this chapter 5. So I think it's in the section 5.1 and 5.1.5. So here it is the activity. So the activity map and LLC sublayer. So here is the instruction to how to answer this activity. So description of the MAC and LLC sublayer are provided in the table. Click in the MAC or LLC field to match the description to the correct sublayer. So hacker characteristic MAC and LCC. So control the network interface card through the software drivers. I think this is the LLC or logical link command control. Then the next one works with the upper layer to add application information for delivery of data to higher level protocols. So this will be, I think LLC again. So works with hardware to support bandwidth requirements and check errors in the bits sent and received. So I think it's a Mac. Then control access to the media through signaling and physical media standards and requirements. This will be also a Mac. Support Ethernet technology by using CSMA or CD or CSMA or NCA. So I think this will be a Mac again. And lastly, remain relative independent of physical equipment. So I think this is an LC. So hopefully guys that all of my answers are correct. Then let's check it out. And then I'm correct. You have successfully matched the description to the correct sublayer. Now that we have done answering the first activity, let's find another one. I think it's in there 2.6. So, activity frame forwarding methods. So, here are the instructions on how to answer this. Description of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through to field to match the method to the description. So the first one, buffer frames until the full frame has been received by the switch will be a I think it's a store and forward. Check the frame. Check the frame for error before releasing it out of its switch port. A full frame was not received, the switch discard it. So I think it's a store and forward again. And then no error no error no error checking on frames is performed by the switch before releasing the frame out of its port. So I think it's a cut through. A great method to use the conserved bandwidth on your network will be, I think that's store forward. And the destination network interface card or NIC, discard any incomplete frame using this frame forwarding method. So this will be the cut through. The faster switching method but may produce more errors in data integrity, therefore more bandwidth may be consumed. This is also the cut through. So guys, let's find out if I'm correct in answering this activity. So let's check it out. Then you have successfully matched the description to the correct frame forwarding technique. So for the next let's find out the next activity. So for the next activity, uh, mhm, this one. So here, here are the instructions on how to answer this activity. Drag the 802.3 Ethernet frame field name to its description. So use path to increase this frame field to at least 64 byte. That will be an 802.2 header data. Describe which higher layer protocol has been used. Describe which higher layer protocol has been used. I think that will be the type. The frame originating NIC or interface MAC address originating from the word originating. I think that's the source address. And assist a host in determining if the frame received is addressed to it. I think addressed to it, destination address. Then notifies destination to get ready for a new frame. That's a preamble. Then synchronize sending and receiving device for frame delivery. I think that's start of frame delimiter. So let's put it in this. Then the text are in Ethernet frame check sequence. So now that we are done in answering this activity, let's check it out if I'm correct for this activity. And then I am correct and then you have successfully matched the Ethernet frame field names to their descriptions. So let's find another activity. I think in this we're done in this activity, and mm, we'll this one. Oh shoot, we're done in this activity. Okay, we're going to find another activity. We're done in this activity. So this okay. I think we are done in doing all of the activity in this chapter. Wait, let me check it. We are done in this, and this one, and this two. We're cleared in 5.1 section. Mhm, mhm. Let's check. So we are done here already. Okay, let's check. Check. Okay. Okay. So now that we are done in doing all of the activities in chapter 5, let me give you a brief summary of this chapter 5. So this is the summary of chapter 5, the Ethernet. Ethernet is the most widely used LAN technology today. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet standards define both the Layer 2 protocols and the Layer 1 technologies, provide the Layer 2 protocols. As it with all 802 IEEE standards, Ethernet relies on the two separate sublayers of the data link layer to operate, the logical link control or LLC and the MAC sublayer. So, at the data link layer, the frame structure is nearly identical for all bandwidths of Ethernet. The Ethernet frame structure adds the headers and trailers around the layer 3 PDU to encapsulate the message being sent. There are two styles of Ethernet framing: IEEE 802.3 Ethernet Standard and the DIX Ethernet Standard, which is now referred to the Ethernet 2. The most significant difference between the two standards is the addition of the start frame delimiter or SFD and the change of the type field to length field in the 802.3. Ethernet is the Ethernet frame format used in TCP/IP networks as an implementation of the IEEE 802.2/3 standards. The Ethernet frames provide MAC addressing and error checking. The layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communication. Ethernet uses the address resolution protocol to determine the MAC addresses of destination and map them against known Internet Protocol version 4 or IPv4 addresses. Each node on an IPv4 network has both a MAC addresses and an IPv4 address. The IP addresses are used to identify the original source and final destination of the packet. The Ethernet MAC addresses are used to send the packet from one Ethernet NIC to another Ethernet NIC on the same IV network. The ARP is used to map a known in IBP4 address to a MAC address, so the packet can be encapsulated in an Ethernet frame with the correct layer 2 address. ARP relies on a certain types of Ethernet broadcast messages and Ethernet unicast messages, called ARP requests and ARP replies. The ARP protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. And the most Ethernet networks and devices are typically connected on a point-to-point basis to a layer 2 full duplex switch. A layer 2 LAN switch performs a switching and filtering based only on the OSI data link layer or layer 2 MAC addresses. A layer 2 switch builds a MAC addresses table that is used to make forwarding decisions. Layer 2 switch depend on routers to pass data between independent IP subnetwork. So now we are done in chapter 5 and we're already answered all the activity on the chapter 5. Thank you guys for watching and hope you learned something about this video. And thank you for lending some of your time for watching this video. So goodbye and God bless.